Okay, this is the Desmos version for the examples in lesson 14, binomial distribution. So our example here, in a computer chip factory, the probability that a chip coming off the assembly line will work properly is 95%. If 6 chips are taken at random, what is the probability that A, exactly 5 chips will work, B, at least 5 chips will work, and C, no more than 4 chips will work? Now, in the last slide, if you watched it from the previous video, you will see that this is the formula for binomial PDF. Now, the old TI-84 has the function binom PDF. It is actually easier in Desmos to use this formula and type it in. Now, what are we looking at in this case? So if I say that I'm taking 6 chips at random and I want to know if 5 chips are going to work, let's talk about the values that I'm going to plug in. The n value, the number of total chips taken, is going to be 6. The r that I want is going to be 5. The p that I want is going to be 0.95, and then if you remember, q is just 1 minus p, so 1 minus 0.95 is 0.05. So if I want to know what is the probability that exactly 5 chips work, I'm going to come over here to Desmos, and I'm actually going to do a table just because I want to show a few things. All right. And so this first column, I'm going to call X the number of chips that actually work. So I'm going to go 0 chips working, 1 chip, 2 chips, 3 chips, 4 chips, 5 chips, 6 chips. And since we're only choosing 6 chips, that's the most that it can be. All right. So we want to type in the formula here. So NCR, and in Desmos you type a lowercase n, a capital C, and then a lowercase r, and then we want to put it's going to be n comma r. So in this case, since 6 chips are chosen each time, and then we want to go x1. Now that's just the NCR bit, so I'm going to close this. Now we want to multiply that by 0.95, and we want to raise that to the x1, and then we want to go times 0.05 raised to the difference of the two values. So we want to go parentheses. In this case, n was 6, so we're going to go 6 minus x1. All right. So the first question was, part A, we want exactly 5 chips. So I'm going to come down here. Each of these probabilities is exactly that number of chips working. So exactly 5 chips working is 0.232. All right. Now for B, at least 5 chips work. Implies, so 4 chips is not at least 5 chips, but 5 chips is at least 5 chips, and 6 is at least 5 chips. So the probability that at least 5 work, all right, so it could be either 5 chips or 6 chips. That would be the probability exactly 5 plus the probability exactly 6. Now we already know what exactly 5 was. It's 0.232. The probability of exactly 6, if we just go back to the table, getting exactly 6 of them worked is 0.7350. And then the total of those two values is going to be 0.967. And that is our answer to part B. Now, part C, no more than 4 chips work. Now, what we could do is we could go through and add up, because no more than 4 chips. 0 is no more than 4, 1 is no more than 4, 2 is no more than 4, 3 is no more than 4, and 4 is no more than 4. So just like in part B, we could add up all of these, or we could say no more than 4 is the complement of at least 5. And I think that's going to be the easier way. So the probability of no more than 4 will be equal to 1 minus the probability of at least 5 work. So we can go 1 minus 0.967, which will leave us with 0.033 as our final answer. Now, population parameters of binomial distribution, you could just multiply the values that you know. N and P you calculate. Q, remember, is 1 minus P, and then the square root of those values. So they're pretty straightforward, and you can just make those calculations with a regular calculator. You don't need a table to do it. All right, that is all I got. Have a great day.